everyone. In this video, we are going to talk about the numericals based on resistivity of a material. So what is a resistivity? Resistivity is one of the properties of the material of which the conducting wire of an electric circuit is made of. And this conducting wire material is depending on three factors. That is the resistance of the circuit, the length of the wire, and the cross-sectional area of the wire. So the relationship is that the resistance is directly proportional to the length of the wire and resistance is indirectly proportional to the cross-sectional area. That means together we say that the resistance in the circuit is directly proportional to the length divided by area. So when you remove the proportionality sign, you put this rho, that is the constant of proportionality, and this rho is called as the resistivity of the conductor. Okay, so we are going to talk about the numericals based on this. The unit for resistance is ohm, unit for area will be meter square, unit for length will be meter, and for rho will be ohm meter. Okay, so you have to convert the length and the cross-sectional area into meter. Okay, am I clear? And then only we'll proceed with the steps. So let's take various different types of questions based on resistivity. The first question, calculate the resistance of the copper wire. So that means I need to find my R, right? Length is given to be 2 meters. Area of cross section is given as 10 raised to minus 6 meters square. And the resistivity means rho is given as 1.7 into 10 raised to minus 8, right? So we have to find the resistance. So R is equals to rho L by A. Okay, that means rho is 1.7 into 10 raised to what? Minus 8 multiplied by L is 2 divide by area 10 raised to minus 6. So what I'm going to do is I'm going to multiply this 1.27 and 2. So 17 times 2 is 34, so 3.7. Now law of exponents, 10 raised to minus 8 divided by 10 raised to minus 2. When the bases are divided, the powers get subtracted. So it will be 10 raised to minus 8 plus of 6. So 10 raised to minus 8 minus of minus 6. I'm just doing it for the first question. The rest you have to remember the law, into 10 raised to minus 2. So that is the resistance of the circuit. Okay, clear? Next, the length of the copper wire is 2 meters. Okay, the resistivity is given as, the area is given as 1.7 10 raised to minus 6. So L is given to be 2 meter. A is given to be 1.7 into 10 raised to minus 6 meter square. The resistance is given as 2 into 10 raised to minus 2 ohms. We have to find the resistivity. Okay, so let's rewrite the formula. What do I mean by that? We know that R is equals to rho L by A. I'll shift the A and the L, so it will change as RA by L is equals to rho, right? So rho is equals to RA, by L. What is R? 2 into 10 raised to minus 2. What is A? 1.7 into 10 raised to minus 6. Divide by A, L is 2. The 2 and the 2 goes off. So you get 1.7 into 10 raised to minus 8, because powers have to be added. Again, you need to remember the laws of exponent which you learnt in maths 8th standard. Okay, clear? Next. Sorry, it's on the other page. Sorry. Yeah. So yeah, the question is going to come up. Okay. Now here they are saying the resistivity of a given copper wire is copper wire of length 2 meters. So length is 2 meter. The resistivity means rho is 1.7 into 10 raised to minus 8. The wire was stretched to a length of 4 meter. So find the new resistance. So nothing is given about the resistance R and A. So we will be assuming R and A as constant, means no major change. Okay, and the new length is 4 meter. So what we are going to say is R1 is equals to R2. Okay, more precisely, area is constant, you can say, and the resistance in both the cases are equal. So there is some change in the length. according to the length, the resistivity is changing, so that there is no change in the resistance and the cross-sectional area. Now we know that R1 means rho 1 L1 by A, and R2 means rho 2 L2 by A. Why I'm putting A? Because there is no change in the area. Okay, now let's put the values. Rho 1 is 1.7 into 10 raised to minus 8 multiplied by 2 is equals to rho 2 multiplied by the length, the new length which has changed is 4 meter. So we'll divide by 4 here. So 1.7 into 10 raised to minus 8 multiplied by 2 divide by 4 is our new resistivity, right? So the 4 and the 2 goes, this is it. Now 1.7 divided by 4 will give me how much? 0.85 into 10 raised to minus 8. That is our new rho, which can be also written as, by just shifting the decimals, in standard form it will be 8.5 into 10 raised to minus 9 rho meter. Okay, what is it? Resistance is equal and area is equal. The change is in such a way that there is no major difference in the resistance and the cross-sectional area. So it's balanced out among the length and the resistivity. Same way, next one. They're saying length, the resistance R1 is 3 ohm. During that time, the L1 is L. Then the wire is stretched to the new length. So that means R2 is what we have to find. L2 is how much? Sorry, 2L. So what about the rho and the cross-sectional area? Rho and cross-sectional area are constant. Okay. So can we say here R1 is equals to R2? So what we'll get, I need R2, right? So what I'm going to do is I'll just shift in such a way that R rho 1 is equals to rho 2. So rho 1 is equals to rho 2. Now we know that R is equals to rho L by A. That means rho is equals to RA by L, right? So here it will be R1A divided by L1 is equals to R2A divided by L2. Correct? Yeah. So what we'll do, we'll put the values of R1, L1 and L2. Area is going to get cancelled off because it's same. So that will be giving me 3 by L is equals to R2 by 2L. Cross multiply. So 3 into 2L divided by L is equals to R2. So I'm getting R2 as 6 ohm. Am I clear? Okay. Next, similar type. Resistance R1 is 4 ohm. Length is L. The new resistance is what we have to find when the length L2 is 3L. Again, rho and area of cross-sectional are constant. Okay, the change is done in such a way that they are constant. So can we say rho 1 is equals to rho 2, which is R1A by L1 is equals to R2A by L2. So A gets cancelled off. So R1 was 4, L1 is 1, sorry, L. Okay, that is equals to R2 by 3L. Cross multiply 4 into 3L divide by L is equals to R2. So 12 ohms is R2. Right? Am I clear? Okay. The changes between the two units are done in such a way that the other two are unchanged. Okay. Right? Okay, it's on the other page. Sixth question. Again, the resistance of 6 ohms is doubled up by folding. So there is a 6 ohm resistance wire is doubled. So we need to find the new resistance. The L was the old length was L. The new length is 2L because it is doubled. So what happened? The initial length is L. The second length is 2L. So you need to find the new resistance. Again, rho and A, area of cross sectional, are constants. So you can say R1A by L1 is equals to R2A by L2, right? Area of cross section is not changing. And you put the values of R2 and L2, you'll get your answer. Okay, I'm leaving this for you. Next, what is the length? You have to find resistance. So R is something which I want to find. So L is 10 kilometer, means it will be 10,000, because 10 multiplied by 1000, which I can write as 10 raised to 4 meter. Now diameter is given as 20 millimeter, means it's 20 divided by 1000 meter, that is equals to 1 by, yes, 50 meter, right? So radius is d by 2, which is 1 by 50 multiplied by 2, which is a 1 by 100 meter, correct? Because 1 millimeter is 1000 millimeters is equals to 1 meter. Okay, now we have to find the area of cross section, which is pi r square, right? So which we'll be doing like this. I'm just helping you out to find the values. So it will be 3.14 multiplied by 1 by 100 the whole square, which is 3.14 divided by 10,000. So we are getting the area as 3.14 divided by 10,000, that I have shifted as 3.14 multiplied by 10 raised to minus 4. So now I am going to find the resistance, because the resistivity is given as 2.7 into 10 raised to minus 8. So let's find R is equals to rho L by A. Rho is given as 2.7 into 10 raised to minus 8. So 2.7 into 10 raised to minus 8 multiplied by the length as 10 raised to 4 divide by 3.14 multiplied by 10 raised to minus 4. Correct? Now 22.7 divided by 3.14 will give me as 0.85. Now this goes up, it will be added. So I'm getting 10 raised to minus 8 plus 4 plus 4, which gets cancelled off. So it's just 0.85 ohms. Right? You can cross check that. So what did we do? We changed the length into meter, diameter into meter, that changed into radius, found the area of cross section, right? And then put the value in the formula of resistivity. Am I clear? Sure. The last question for today. The area of cross sectional is what we have to find. So A is something we don't know. The length is given to be 1 meter. The resistance is given to be 23 ohms. The resistivity is given as 1.84 multiplied by 10 raised to minus 6 ohm meter. So what we'll do, we'll take the formula of resistance and we are going to change it into and plug it. Okay, so that means what I'm going to do is, sorry, R is equals to rho L by A. Shift the A on the top, so it will change rho L by R, which is equals to 1.8 into 10 raised to minus 6 multiplied by 1. Why? Because length is 1. There is no change. Divide by resistance is 23. So 1.84. Sorry, I made a mistake here. The resistivity is 1.84. Sorry. So sorry. Now 1.84 divided by 23 will give me a 0.08 multiplied by 10 raised to minus 6. I can write this 0.08 as 8 into 10 raised to minus 2 multiplied by 10 raised to minus 6. So that will change as area is equals to 8 multiplied by 10 raised to minus 8 meter square. Am I clear? So we did look into different various questions based on resistivity of a material.